Hey, welcome to the soldering workshop. Let's get started. Okay, so for today's tools, we have a soldering pump, wire strippers, soldering iron, solder, and safety glasses. So yeah, so the pump is used to remove solder. Wire strippers is to expose the metal on the wires so you can solder them. And then the soldering iron is to heat up your solder and to apply it, and your solder is just what you're heating up. And safety glasses because sometimes it splatters, usually on your hand, but you never know. So better to be safe. Okay, yeah, soldering iron. So common stuff. Let me turn on my video. Can you guys see it?
Yes.
Yeah, we can see it.
Okay. So yeah, iron. Move it closer. Don't touch the metal part because that's what heats up. Place it back into the holding stand when you're done, and unplug it when you're done with it. And sometimes the stand can get hot because it's in contact with the soldering irons metal part. Just be careful of that. Um, yeah, yeah. So types of solder. So usually it comes in forms like this in a roll, metal in it, and you can unroll it. Um, so yeah, they come in different widths as you see in the picture. There's I don't know what measurement that is. Is that millimeter? Yes, it's millimeters. So what I have right now is 0.8 millimeters. So it's pretty thin. It should be fine for what we're doing today, which is not that big. Oh yeah, and there's lead-free versus leaded. So leaded is older, easier to melt, and it's cheaper, and lead-free is more expensive, but no lead, which lead poisoning is a thing. So if you're working with leaded solder, which what I have here is leaded, just make sure to clean up and limit your exposure. And that's why I have a mat too, to not get like all over the place. More safety, yeah, safety glasses. Solder can splatter, usually on your hands. Wash hands, limit exposure. Try not to inhale fumes, which is why I have like a little fan thing here to like suck up all the fumes. Okay, so the components we were working on: resistors, buttons, LEDs, and a perf board or prototype. Um, everyone familiar with what these do? Yeah.
Any questions about the components?
Questions? I guess not. Silence is agreement. I don't know. Next. So this is what we're working with today, or we're going to be trying to solder, which is basically a circuit which, when you press the button, the LED lights up. And go. Yeah. So then, how to solder? So the idea of solder is to place the iron on the thing you want to put the solder on, and so heat it up, and then you add the solder. So it's not going on the iron, but onto the component. So right here you can see, heat the part up, add the solder, step 2. So you continue heating, and then 4, let it cool. So, and then on the bottom shows the different like qualities, I guess. So volcano-like shape is perfect. Bubble is probably too much. If it's like not coming out of the hole, it's not enough. And cold joint, I'm actually not too sure what cold joint. And then too much heat, you burn the part. And this is a short because it's connected between 2 terminals. And make sure to use the whole iron, not just the tip. It's free real estate. So there's 2 variations. What we're working with today is like a perf board, so it has holes inside the thing where you stick the components through, like so, and then you would put solder into the hole and the component. There's also surface mount, We're not working with that today, but it's where the component sits on top of the board instead of the legs going through. Yeah, and that is it for the slide part. Any questions? Okay, guess not. So let's get to the technical part. Okay, so first, before we solder anything, a good idea is to build it on like build some sort of prototype, like on a breadboard. So over here you see we have the maybe I'll bring it closer. We have the LED and the resistor and button, just like exactly in the schematic, with the 5-volt source right here. And then when we click the button, the LED lights up. I don't know if you can see that. Yeah, I can see. Any questions on like breadboarding? I guess Daisy?
When you solder on it, you want to make sure it's off, right?
For what?
When you solder for your components, do you want to make sure it's off? Or
Oh, the breadboard?
yeah.
Oh no, we're not. This is just like a prototype, so it's like a nice, convenient way. So we're gonna be soldering onto this thing right here with like the bunch of tiny holes on it.
Oh, okay, I see.
So this is just to like make sure our schematic works, like our circuit, before we do anything semi-permanent, just to make sure our circuit is working. And it seems like something happened to the circuit. The heck?
Yeah, it's a hero.
Did I disconnect something? Oh no, it's not working now. Huh. Interesting. Wonderful. I screwed up something. Maybe it's the
The
wires.
importance of testing, because if he didn't test it and he went straight to the board, then that issue would have been already on the board and it would have been difficult to fix it.
I'm sure the issue is just my wiring, so I'm just gonna plop it. Okay, here we go. So now it works. So we can now replicate that to the prototype board. Yes. So actually, let's try using these components since we've already verified them. Since I don't have really a 5-volt battery anywhere, so I'm just gonna end up plugging it back into these. So I'm gonna strip some wires so I can have some connectors. Let's see what I have. Black wire is already good. So I'm gonna shorten them. Let's cut. And I have the cheap version of strippers. Wire strippers right there. It's okay. Just put it in. Push down to cut the rubber and then pull if you're strong enough. And then rubber should slip off and now you have exposed piece.
So is there a specific, like, I know because wires are measured in gauges, like a specific hole we're supposed to put it? Because I see that there's different sized holes on the tool.
For general, I just eyeball it and put it into the hole that fits. Because usually the next one is too big for the actual wire. So usually it's like a hole where you can see it's like gonna cut in versus not. But yes, there are different types of gauges of wire. So you always want to go like just like small enough so that it cuts into the rubber and not like into the middle. So here we go. Okay, so we have our wires, LED button, resistor. All right. Okay, so some of the extra tools I have over here are this solder cleaner. So in the cheap kits, you'll see like you'll get like these sponges which you wet to clean up your iron, but those aren't that good because they cool down your iron, and I just find they don't really do anything. So to use this, you just push it in and like rotate, should clean it pretty well. Mhm. Next. Ready. And I also have this stand to like hold it.
It's actually those things like
So what I'm gonna do right now is like replicate this schematic on this board, which we just tested at first. So I'm just gonna hold it. Mhm. Right. Right. Okay. So let's get the LED in first. So first thing I'm gonna solder is the LED. Notice, make sure the polarity is correct. The longer leg is positive. So just keep that in mind so you don't do it backwards. So shove it in. Wait. Let me make sure. So first you put it through the hole. Um, Usually you want to go from the bottom, but because you're gonna have to connect the components. Okay, I'm just gonna go from the bottom. So sometimes this is like a little bit hard to work with, so you could just like snip it. Now you have like a little manageable piece. I don't know if you can see it. Okay. Right. So the first thing I like to do is just put some solder on the tip just to like help with heat conductivity. And then what we can do is put the soldering iron on the component and the metal plate, and then you add solder to it. And there we go. So let's show this. So can you see this? Is that visible? So notice how there's like
That's perfect.
a bump on the wrong side. Notice how there's a bump
Oh.
on the thing. It's not too much. Actually, it might be a little bit too much.
You are a pro, Sonny.
Okay, so let's do the other leg. Just come out. I'm gonna be cleaning this very often because I want to keep it clean, so we don't have any reduction in our like heat transfer and build up on the soldering iron. So again, we put the soldering iron on the component and we add solder to it, and that leg done. Um, any questions so far, Daisy? No. Okay, so next we need the resist. Right, so I'm gonna have to decide where the next piece, the resistor goes. So I'll just stick it whatever I can. So it looks like negatives here. Let's put it through here. So that seems to be pretty convenient. And now we'll just do the same thing. Solder on to help it conduct heat, and then iron onto the leg and add solder. That one was not as clean as I hoped. I guess. And then same for this one. Heat up the component. Just on. So now we have the resistor and LED on. We just need the button. We'll use this. See if we can or cannot turn it around without it falling. You cannot. Actually, I've seen a trick on this for this one. So I found this trick where you can't get it to fall off. You could just put a little bit of tape, hold it in temporarily. You shouldn't heat up the component to where it'll destroy it, so it should be fine. Just move that aside. Okay. So we'll try to do this one as quick as possible. So again, heat up the component and then, oh, yeah. So right there, I didn't have enough conductivity because I didn't tin it first. Now you add it. So now we have all our components soldered onto the board. What we're missing are probably like the red and black wires, so we can connect it to the breadboard easier. So I'm just gonna add those in. Just connect it right there.
If this material had enough.
So you might notice the smoke coming off, but that's where we have like some sort of fan. Should be higher, but in this case, there's actually a little bit too much solder. Just black. We'll put the next wire over here. Really just replicating the breadboard design.
Here's the sides.
Please work. Okay.
Try time.
Let's try to see if this is gonna solder. Nope. Yep, let's just make a strip a new line for this. find it.
Hmm.
So I believe where we want it is this hole right here. Oh, straighten it out. Okay, this one I'm gonna have to hold a little bit because actually, nah. So he on, and then add solder. Should be good. So as of now, we have all these components. Make sure they're tight. They shouldn't come out with any force or reasonable force. Let's see. Yes, so of course, their terminals right now on the bottom are soldered individually, so they don't have the internal connections like the breadboard does. So we're gonna have to connect them by making traces, which is like basically lines of solder that go between the terminals we want to connect, which is pretty simple. You just put your soldering iron in the middle of the two terminals you want to connect, and you add solder onto it. First, actually, go. Let's- Yikes. Okay, so which ones do we need to connect? Yes, so these two terminals are here. So when your solder gets to the point where it's super short, you might want to replace it with a fresh one, or else you might get splattered. It's getting kind of close now. So go ahead and do that
I'll put the card
right there. It seems connecting. There we go.
watching people get started. Because I'm putting a
Respect.
cryofield and it's getting immune.
Okay. So now that we've done all the internal connections, we should probably
I've been watching you
Test
for
it.
5 minutes.
but so I'm just gonna do like a real like since I don't have a battery, I'll just connect it to the board and test the circuit out. See, there we go. No battery, but it's functional.
Nice.
So a final note is that these legs are kind of long on the bottom, so you can snip them once you're done. Like so, just grab this and just go along here. Turning it away so it doesn't get everywhere. There we go. So now we have a nice little circuit. One thing I forgot to mention was the use of flux, which helps prevent the I think it was from like the oxidation forming. So if you ever see videos of people melting metal, there's like a layer of slag on the top. Just kind of don't want that reaction with oxygen. So that's what flux is. So it usually comes in this, so it like forms like a can where you can just dip your wires in and then add solder. There's also flux like rosin core solder, which is what I have right now. So it's in the middle, there's like some flux, so you can use that too. Once you're done with the iron, it's a good idea to clean it, which add solder and then twist inside the cleaning thing. Add some more maybe. Yep. That's basically it. Any questions?
So why did you add the little bit of solder again at the end?
Oh,
Like
just
on the-
to protect it from anything. S- I was told to do that by like our previous electrical lead. So that's the way he did it when he told me to. He mentioned it was like a way to protect the tip of the soldering iron.
Oh, nice. Thank you.
And the temperature I used was around like 300 to 350, which Chris said is like optimal. So
Yeah, if you use anything higher, like let's say 400 to 450, you kind of risk burning the solder too quick, and you won't be able to get a good contact on the board.
oh, so this is like onto like a prototype board. There's also another thing you should know, which is how to solder two wires to each other. So basically it's pretty simple. So you take the two ends and you like interweave them together and then you twist, give it a nice twist. So now they're sort of connected, but they'll come out if you pull it. So is this thing heated up? No. Just wait. So what you are going to do is you're going to place your iron on it like usual and then add solder like what you did before. It should pretty much come together. Just wait for this to heat up a bit. You can usually test how hot it is, but just seeing if it's gonna melt it because it should pick it up pretty quickly if it's up to temp. Which it's not.
Oh,
We'll just wait. In the meantime, is there any other questions?
that's all this. It's fine. It's fine.
I have a question. What is
Mhm.
that blue thing that you have at the bottom of on top of your desk?
This one?
Yes, the blue mat.
Oh, the blue mat. Oh yeah. So this mat is to help, like it's pretty heat resistant, so it'll like help contain any solder that might drip off if you add too much. And so it also protects your desk from the heat exposure, and so you don't burn it like some of the desks we see in the solarium. um, the and also it'll keep like your lead exposure because to a minimum because all the solder is supposed to land on this instead of all over your desk. So it also helps you with cleanup. Now let's test if it's hot enough. Almost. Almost. So usually this fan would be turned up pretty high. Here's max, but it's pretty loud. That really just sucks in all the smoke. Make sure it captures all of it. Because you should be trying to not breathe in like this stuff, since it is like leaded, the solder. Of course you can get unleaded. It's still limit exposure to any chemicals. So like before, heat on and then add the solder. I can aim it properly. Oops. All right, so now you have two wires stuck together now. Test to try to pull them apart. No, I can't. Yeah, it's pretty solid. So to remove solder, there are two ways that I've been shown. So there's the wicking material, which is looks like that. It's copper colored, comes in like rows. And then there's the sucker, which is very supposed to be accurate. And you click this button, which will launch this thing up. So those are the two ways I've been shown. With this one, to remove it, you basically have to. You basically put it on the solder that you don't want, and then you put your iron on top of it, and then this will wick up all the solder that you want to get rid of. But be careful because the wick itself can get hot. So the solder gets stuck on this, and then you can cut off whatever part you used and keep going. For this one, it's kind of different. Say you want to remove some solder from the hole. This one's especially useful for like these tiny holes. So you heat up the solder in the hole, and then you just hit the button, and it should suck it all up, and then it should come out. So those are the two ways for removing solder from stuff. I personally find this more useful for like the small holes, like the prototyping board. And this one's more useful for like if you have wires and you want to suck some of that. So generally large areas. So that's basically all I have. Any more questions?
What's the little sponge for?
What was that?
What's the little sponge for? The one
Oh,
you
the
like-
little sponge. Okay. So this is also another way with like the cheaper soldering kits, which was like the ones that showed you the link at first. Like they come with these sponges. You like wet them and then you give them a squeeze so they're not like too wet, but they're still damp. And the idea is to like clean your solder on them by like going like flat on the side. But so like just do like that motion. But
Oh, so it's like wiping off the solder.
they're really not that good because they cool down the tip of your iron. So like when I used it, the solder would kind of just beat up and like avoid the sponge itself. So usually we have these, so like it's like wire inside, like this stuff, and then you just stick it in and you twist, and that should clean it pretty well. I believe these are the variety we have in the Solarium, so they're pretty useful. So I don't use the sponge anymore, so
Thank you.
Any more of the questions, comments, concerns?
threats, no, just kidding.
Okay, I think that concludes the workshop. So I'm gonna stop recording.